Let me share with you today an original discovery, but I want to tell it to you the way it really happened, not the way that I present it in a scientific meeting or the way you'd read it in a scientific paper. It's a story about beyond biomimetics to something I'm calling biomutualism. I define that as an association between biology and another discipline where each discipline reciprocally advances the other, but where the collective discoveries that emerge are beyond any single field. Now, in terms of biomimetics, as human technologies take on more of the characteristics of nature, nature becomes a much more useful teacher. Engineering can be inspired by biology by using its principles and analogies when they're advantageous, but then integrating that with the best human engineering ultimately to make something actually better than nature. Now, being a biologist, I was very curious about this. These are gecko toes, and we wondered how they use these bizarre toes to climb up a wall so quickly. We discovered it, and what we found was that they have leaf-like structures on their toes with millions of tiny hairs that look like a rug, and each of those hairs has the worst case of split ends possible, about 100 to 1,000 split ends that are nano-sized, and the individual has 2 billion of these nano-sized split ends. They don't stick by Velcro or suction or glue, they actually stick by intermolecular forces alone, van der Waals forces. And I'm really pleased to report to you today that the first synthetic self-cleaning dry adhesive has been made. From the simplest version in nature, one branch, my engineering collaborator Ron Fearing at Berkeley has made the first synthetic version. And so has my other incredible collaborator, Mark Kutkowski, at Stanford. He made much larger hairs than the gecko, but used the same general principles. And here's its first test. That's Keller Otta, my former PhD student, professor now at Lewis and Clark, literally giving his firstborn child up for this test. More recently, this happened.
This is the first time someone's actually climbed with it.
Lynn Verinsky, a professional climber who appeared to be brimming with confidence.
Honestly, it's going to be perfectly safe. It'll be perfectly safe.
How do you know?
Because of liability insurance.
With a mattress below and attached to a safety rope, Lynn began her 60-foot ascent. Lynn made it to the top in a perfect pairing of Hollywood and science.
So you're the first human being to officially emulate a gecko.
Wow, and what a privilege that has been.
That's what she did on rough surfaces, but she actually used these on smooth surfaces, 2 of them to climb up and pull herself up. And you can try this in the lobby and look at the gecko-inspired material. Now, the problem with the robots doing this is that they can't get unstuck with the material. This is the gecko solution. They actually peel their toes away from the surface at high rates as they run up the wall. Well, I'm really excited today to show you the newest version of a robot, StickyBot, using a new hierarchical dry adhesive. Here's the actual robot. And here's what it does. And if you look, you can see that it uses the toe peeling, just like the gecko does. And if you could show some of the video, you can see it climbing up the wall. There it is. And now it can go on other surfaces because of the new adhesive that the Stanford group was able to do in designing this incredible robot.